Afternoon, everyone. Um, we're back. We're going to look at the map function, and we're going to bounce all over the alphabet with this one because there's so many related. And not only is there map, there's map accum right, map keys, map object indexed. There's add index, which we looked at in the previous theories that Chris did. Um, so let's just get into it. Let me go back here, look at map. And map is everyone's gateway drug to functional programming. Um, it's generally the first thing you learn using the map method on the array prototype. And it's kind of our introduction into higher order functions, which are functions that take a function and return a function, or they could take a function and or return a function, I think is the more correct way. And we're going to look at functors because we need to know that concept and it's not too hard. So this will be a very general and gentle introduction to category theory. Yeah. So if we look at the type signature for map, um, F is a functor, which we're going to look at in a minute. That being said, the map function in Ramda only takes one argument, where the that differs from the map function on the array prototype, which takes three arguments. It takes the element that we're currently iterating over, the index of where we are in the iteration, and then the array itself. Um, but this one, we just take a function. It takes an A and returns a B, and then we give it A, which is a functor, and we return a B, which is also a functor. Let's see if there's any tidbits in here. The function to be called on every element of the input list. So that's, you should be familiar with that with using array.map. The list, it be iterated over, and then it returns the new list. Nothing crazy there. So it takes a function and a functor, and it applies the function to each of the functor's values and returns a functor of the same shape, right? So this is actually what's called an endofunctor, an ENDO functor. And that just means it maps from one type of structure to the same type of structure. Sorry. But let's click on this and let's see what it says about functors. So a functor is a data structure. Think of it like a box. And the box, to be a functor, the box has to obey two laws called the functor laws. And those functor laws is identity. So this is kind of crazy. Ignore that much of it. But A to A, that's like the identity function in Ramda, r dot identity. Um, and it's saying that if we take a value and return the same value, it's the same as identity. The second law is the composition law, which means that if you take an X and you apply G to X, and then you apply F to the result of G of X, it's equivalent to applying, uh, composition, like G, applying G to X and then dot F to X. Um, so that's not meant to be a great explanation, but the takeaway from that is to be a functor. Um, the structure has to obey these two laws, the identity law and the composition law, right? So, and the only thing that it needs to have, the only method it needs to have on it is the map method. And so we know that our array has a method, or arrays in JavaScript have a map method on them already. So an array in JavaScript is a functor. That's the takeaway. Um, and if you look at the signature, it's basically just what we saw. There's this weird squiggly arrow. I'm not exactly sure what that means, but if we ignore that, it takes a function. Actually, this is a little backwards. Takes a functor of a's and a function from a to b, and then returns a functor of b's. But that's okay. But the takeaway is it has to obey the identity law, the composition law, and have a map method, and it is a functor. And if it maps from like an array to an array, then it's actually called an endofunctor because those are in the same two categories. Um, if you want to learn more, I recommend several books. The one I really like is Professor Frisbee's Mostly Adequate Guide to Functional Programming, and they get into that one. It's don't read it too fast. It starts off pretty easy, but it starts to get a little complicated. So now that we have this rough idea of what a functor is, and we've used map before, I think we can have a general idea. Now, the cool thing about this is Ramda provides suitable map implementations for array and object. So we can map over an object with Ramda's map. You can't do that in regular JavaScript. So the function can be applied to one, two, three, like an array, or it can be applied to an object with x is one, y is two, z is three. And then it gets into this advanced stuff that we're not going to worry about. But we're going to take a look at add index, pluck, and project as well. So, you know, just a simple version. Get r.map and provide a function. We could say r.multiply 2, which is like a double function, and then pass it a list. And I'm going to use my some data package. I'm going to use d.list, which is an array of 1, 2, 3, 4, 5. We should get 2, 4, 6, 8, 10. And that's what we got. So that's pretty cool. If I log out d.obj, which is this random object, we get an object with the ID of one, name of test, and active of true. Uh, so we can map over that, but I don't know what we would use as a callback function because this is a number, a string, and a Boolean. But we could do, so let's change this to obj. We could do identity just for kicks. We should get the same object back, and we do. Um, let's see, what could I do? What if I add one? I mean, that's gonna be two and probably test one, and this may coerce to one and give us two. You never know until you try, right? That gave us not a number. Yeah. Yeah, no, okay, because what was the original object? Yeah, test. I mean, if it was like a string of one and we added one, that would give us two. But that gave us not a number. But the point is that we can map over an object, but when you do, it keeps the properties the same and it just maps over the values of those properties. If you want to map over both, there's a different function for that that we'll look at. So yeah, that's your map um, and a gentle introduction to functors. And in this case, since the object has the map method on it, or you can map over an object would be considered a functor in this case as well. But generally it's not, unless you go in and add a map method. Um, and you could always do like object.entries and object.from entries to convert a map, an object to a um, list of pairs, and then map over that, and then convert it back to an object. And then in Ramda, that's to pairs and from pairs. Yeah, so that's map. But let's look at okay, let's look at add index, because if we did d.list, which is 1, 2, 3, 4, 5, and then use the map method that's built into JavaScript, the array prototype, we're going to get, let's see, what do we get? We're going to get the item in the array, we're going to get the index, and then we're going to get the array itself. And then we could just, I mean, we could just return that in like in an array, maybe, like group them together in tuples. So we could say x, I, x's, just so we can see what we're getting. And we get rid of this. Yeah. So 1, 2, 3, 4, 5, that's the original array items. 0, 1, 2, 3, 4, which is the indexes, and the original array. And I always wondered, like, why do you get the original array? Because we're saying d.list, like we've got access to the original array right here in scope. So why even pass it as an argument? But then I'm thinking, like, what if you had a pipe and then you did, I'm just going to pass this directly d.list, like that's the array. And then if we were to r.filter, and then we have to flip to make it logical and say r dot greater than 2. I always get confused about which is checking which, but not there. Filter, flip, r dot greater than 2. What am I doing? Um, yeah, list 1, 2, 3, 4, 5. Well, let's do app log so we can see it there. But I mean, we're going to get 1, 2, 3, 4, 5. Ah, I know. I do this all the time. We're flipping the less than. That's all we do there. And then we provide it the argument. Yeah. Yeah. And then let's go back to greater than. So we're going to filter. Sorry, this is a side note anyway, but like we're using the list in a pipe and we're filtering it and we're getting the values that are greater than 2. And then let's say we map that. R.map. Um, but first, actually, what we want to do is we want to add an index where it says C add index. I'm not going to go to it, but this basically decorates the function, the map function, with the index and the original array so that it would behave like the built-in version. So we do that to map, And then now we have that index. So we could do our callback function and pass it the x, the I, the x's, and return a tuple of those. All right, so we get 3 and 4 and 5, but then 0, 1, and 2, and 4. A different array. It's hard to see here. No, no, no. 3, 4, and 5. 0, 1, and 2 are the indexes. And then 3, 4, 5, 3, 4, 5, 3, 4, 5 is the array that's being passed in. So the reason they give you the x's, this is my whole point, is that if you're in a pipe, you don't have access to those x's, right? Because you're inside this function. I mean, presumably that d dot list is somewhere in scope, but I think this is why you have access to the x's, and you rarely use them with a map, like unless you're needing to compare this x to this x's for some reason. So that's what the add index does. All right. Um, so it says C pluck. Let's go look at pluck before we get into map accumulator. Um, so the reason they say C pluck is that it also uses a functor. So here the F is a functor, and this is like a fat arrow. So this is not part of the actual type signature. This is just telling you the F here and the F here is going to be a functor. This one takes a key, so like object key, and then it takes a functor, an object which is a functor, which has a key value pair, and then it returns a V, which is a functor, right? So it returns a new list by plucking the same named property off all objects in the list supplied. Pluck will work on any functor in addition to arrays, as it is equivalent to r.map, r.prop with k, and then a functor, right? So let's take a look at that. Let's look at the first example they give us here. Notice they're using var, and that's old school. All right, so we make this function called get ages that uses pluck, and then we're passing in age. So that's the k, right? And then we're going to pass the second argument, which is going to be our object, a functor of objects. So it could be a list of objects like this. So here we're just working with arrays, not objects. I mean, an array of objects, but still the main structure is an array. So we got Fred and Wilma and their ages. And then if we run that, oh, we're going to get 29 and 27, right? So what we're doing is we're literally just plucking out the value of the ages out of all the objects in the list. So that's pretty useful because, we deal with a lot of arrays, especially a lot of arrays of objects when we deal with data, fetch requests and such. But we can also pass in, let's look at this one here. Just all in one line. Let me clean it. All right, so that's pluck. So the first argument is value. The second argument is this object. And if we run that, we get an object with the A and B properties and 3 and 5. So what we're saying is we want to pluck out the value of these objects. But what it gives us back is the same shape. Like this object has an A and a B. And then it's just for the values, it's just giving us the result of the key that we pass in. So it's pulling this value out of this object and just assigning it, kind of like overwriting this, even though it doesn't overwrite, it doesn't mutate, but that's what it looks like to us. Um, so that's what pluck is. And we're going to continue and look at these other ones because they're pretty simple and they are all slightly related. Basically, about being able to conveniently get things out of an object, get values out of an object. So if we go to prop, we have this type constraint, which for index, which means it's a string int or symbol. And so we pass in an object with a um, string is the key, and then anything is the value. And it's going to return either A or undefined because the ID that we pass in, or the index that we pass in, may not exist on the object. And if so, we get undefined. If it does exist, we get the thing back. And it says returns a function that when supplied an object returns the indicated property of that object if it exists. So this one's super simple. Let's use our d.obj, which looks like that. And then say we want to get the value of name. We could just say, well, let's partially apply it. We could say get name and then r.prop. And one of the reasons I'm looking at this is code examples make heavy use of this prop. So as simple it is, we might as well know what it is. You just pass the key as a string. And now we've got this like this get name function. And we give it an object and it'll give us the value of the name. So if we do get name and pass in the d.obj, we get test. We can make another one called active, call it is active, and then apply that function to the object, and we get true because active is true. So that one's easy. And then just make sure there's nothing in here. Property name of or array index. It looks like we can pass arrays. Let's just try it real quick. Let's do d.list, which is an array of 1, 2, 3, 4, 5. R.prop. But you have to pass it an index, and it could be a string, but it could also be an int. And arrays are objects with the indexes already created as integers. So I could say, get me the third index as a number, not a string. And that should give us 4, I think. Yeah, and we get 4. So if you want to do it like that, you could pretend, or not pretend, but you could consider that the array is an object, and array objects have properties which are integers, and you could use it like that. And let's also look at props because this is similar. It acts as a multiple prop, array of keys in, array of values out, and it preserves the order. So again, let's steal their example here. I'm not spending too much time on these because I feel like these are pretty straightforward. And I want to get back to the map, Cume and all those because those are not built in, kind of things. So just get rid of some parentheses here. So here, instead of just passing the x and saying give us the value of x, we're saying we're passing a list of things that we want to get back, or a list of properties where we want to get the values of those properties back. And we get 1 and 2 because we want x and y. If we said x and y and z, we would get 1, 2, and undefined because there is no z property in our array. And again, we could probably pass it in our d.list, an array of 1, 2, 3, 4, 5, and pass in an array and say we want to get the 0th item and the 4th item, or the item at the 0 index and the item at the index number 4 out of that list. And then we get 1 and 5 because 0 is the first item in the list and 5 is the last item, which is at index 4. So that's how prop works, or props works. And then the last one we'll look at in this video is project. And this one's pretty cool. I love the description. A reasonable analog to SQL select statement. So if you've worked with any SQL before, um, sometimes people pronounce it SQL, sometimes they pronounce SQL, but the correct pronunciation is squeal. It's truthy. Anyway, so it's something like select all from my table. This is pseudocode. That would give you all the record, or the fields in the table, for everything. But you could say, I can't remember the syntax. I don't know if there's parentheses or not, but you could say get like name and ID and give it an object, something like that. So that's what they're saying. It's an analog to the SQL select statement, but it's pretty cool um, that you can do this. So again, I'm going to just steal this much at least. So here, like, imagine we had a database and we've got this Abby person with their name, age, hair, and grade, and Fred, same properties. And then we just make a list of these people, right? So we could have done this all in line, but this is nice and separated. And then we're going to project. Let's do it like this. And we haven't even looked at the type signature. So it's an array of no, it's not. Yeah, it is. It's an array of keys. We pass the things that we want. So let's say we want age and hair. So we pass that in. So these are the things that we want to get back. And then so it takes that, and then it takes a list of objects with key value pairs. And that's what we have here. These are the objects, and we put them in here. Now it's a list of objects. So we have our kids. Put this on a different line. And so what we're like, project age and hair from the kids, or that's very similar to saying select all the ages and hair color from the kids list. And it's going to give you back a list of objects with key value pairs. So let's run this. And then we get an error. Ah, Yeah, it's just like prop and props. These need to be strings because they're just because they do. That's just syntactically the way it works. Yeah. And so we get a list of objects back, like we were promised, where we have age is 7, hair is blonde, and then the next record, age is 12, hair is brown. So a lot of different ways, we've looked at project, props, prop, and pluck all do the same general thing. They grab the value of a property or properties out of an object or a list of objects. Um, and they're all slightly related. I know we've gone down several levels of rabbit trails here, but if I go back, but yeah, the key is that the pluck makes use of these data structures called functors. And an array is a functor, and a map can be a functor if it has a, no, sorry, an object can be a functor if it has a map method on it. And JavaScript or Ramda provides that map method. Yeah, so that was a long one. Then we'll just pick up on these slightly more generalized versions of map, the map accum right. These are very similar. Map keys and map object indexed, and then we'll be done with the maps. So thank you for spending your time with me. Tell a friend, and I'll see you in the next video.